right, today, hello, we're going to talk about compounds today. All right, a compound is two or more elements combined chemically together. When you do chemical bonding, the electrons from one valence shell go to the other. So you're basically just sharing electrons. They come together and they make a pure substance, which is a compound. All right, in a compound, there's the law of definite proportions. So if you have a compound, every piece of that compound is going to be that compound, right, in a pure substance type thing. So if I have a water compound, it's going to be H2O no matter which part you take. All right, if I have pure H2O here and I just take a sample out of it, I'm not going to find carbon dioxide in it if it's a pure substance. If it's pure water, right, it's going to be H2O everywhere, right, no matter what. Same thing with table salt or NaCl, sodium chloride. No matter where you take table salt, it's going to be table salt, right? That's the law of definite proportions. So the actual definition is any compound contains exactly the same elements in exactly the same proportions by mass. There are actually several thousand different compounds. One example is carbon dioxide. That's carbon and oxygen. A molecule is two or more atoms combined to make a compound. Smallest unit, a compound, can be divided. So if you have a compound of water, a molecule is the smallest one it can be broken down to, and then you break that molecule down into your different atoms if you want. So what you need to know about that is a molecule is the smallest unit a compound can be divided. And bonding, properties of elements are lost when a compound is made. So when you do a chemical bonding, so when you do water, you take two hydrogens and combine it with one oxygen, and you get H2O. All right, water does not look like hydrogen, it does not look like oxygen, but you combine them together and they get water. They lose their properties and they gain a new one when the chemical bond and make a compound. All right, chemical formulas. So this right here is carbon dioxide. All right, this right here is what is called a subscript, and it shows how many atoms there are of that. So in this case, there is no subscript there. So in this case, I have one carbon atom, and I have two oxygen atoms. All right, that's all that subscript means. We come over here and look at this one. This means I have 12 atoms of carbon, 24 atoms of hydrogen, and 12 atoms of oxygen. So in total, I have 48 atoms here, and over here I have 3 atoms. And that's just how they're named. All right, but then it goes into a little bit more specific naming depending on what you're combining. All right, the first thing you need to do when you do chemical bonding or where you're trying to name these is find out what you have. You need to know if it's a metal or a non-metal. All right, and then you have certain rules that are based on that. So look on your little periodic table you have and see what's what. So if you have a metal and a non-metal, so my example here is table salt, or NaCl. So you put the metal first, which is your sodium, and then I place my non-metal, which is chlorine. All right, but then I add an I to the end of chlorine. So this becomes sodium chloride. Now this is only for a metal and a non-metal mixing together. All right, don't do this with two non-metals or something like that. Always check to see what it is first and then combine it based on the rules that you have. Another one will be So this is, my metal is lead here, and then my non-metal is sulfur. So I take the lead, put the sulf, take the UR off and add I. Lead sulfide. So that is basically how you do a metal, non-metal compound when you name it. Put the metal first, non-metal, take off the end, and add ide. So when you name non-metal compounds, you use the prefixes mono, di, tri, treta, or whatever, but you don't use mono on the first one. All right, you can use it on the second one. So you can say like dinitrogen monoxide, but you can't say like carbon dioxide. All right, you're not gonna say monocarbon dioxide. No, you'll never use mono on the first element, but you use it on the second. So some of these examples, and I find it's best just to do examples for these, is SiO2. So that's silicon and oxygen, or silicone, whatever you want to say. All right, so I'm gonna add the di and the tri to it. Silicon and oxygen, so you'll say silicon dioxide is your answer here. I'm only gonna do two. So CCl4. So then I have carbon tetrachloride. Carbon. Spelled weird. Make sure you add the ide on the back with it on front. Well, I'll do another one just for it. These are just some examples. N2O. So you get dinitrogen there's one, so it's monoxide. There you go. So just make sure you name those right. It's difficult. I mean, there's different rules for everything. You'll get caught up on a bunch of different stuff. But just make sure you add that I to the back when you use non-metals. All right. So ide. Just make sure you always add it in there. And just for good measure, the last one is magnesium and chlorine. So I add the I to it. And I have two of them, so I say dichloride. So magnesium, because it just has the one, I don't add the mono on the front, magnesium dichloride. This has been Compounds. Hope it helped. I hope it helped.